Hello, this is Rick Guptill, and we're going to use TrueSim today to show how we would weld a part on this machine. This is a 3-axis robot with an XYZ gantry setup, so it's got pretty good reach. We're going to use a solid model. It's a step file format. We're going to say we're going to use this inner part here, and it's looks like it comes from the 2000 series. Our philosophy for welding is to identify subparts, the base and the subparts, and then give subparts certain characteristics so that if we encounter them again, we can weld them. If they're moved a little bit, it doesn't matter. We don't want to just click on surfaces and get welds, because then if there's slight variations, we'll have to do it every time. But we're hoping that when the part is completely specified by our weld family algorithm that we're just about to do, then you'll get a good idea of how they're specified, and then the next time the system sees it, it can just automatically create the welds you need. Okay, so the first thing we're going to do is open solid weld, and we'll select the part, and we're going to select the family. Well, there is no family yet because we haven't taught it, so we're going to teach a new family, and we're going to call it 2000 series, for lack of a better name. Now there's three kind of parts on here: base parts that we weld to, subparts that are going to be welded to the base part, and then non-welding parts. And in this example, this has a case around it, so we're going to take off the case and we're going to declare those as non-welding parts. In addition, these things here, we don't weld subparts to subparts in this algorithm, so we're going to take those off, plus they're going to interfere with the robot. And then this one's up to us. We can either use this is welded to the subpart, but it interferes here, and I'd rather have a straight weld on here, so I'm going to call this a non-welding part, but we could go back and we could select that as a welding part. Also, this is these guys are non-welding parts. And then what we can do is there's a lot of, looks like there's some other parts right there. I'm going to say those are non-welding parts. And then there's parts that are on these kind of parts. We'll take those off too. So we first clean those up, and then base parts are kind of like these parts that are everything's going to be welded to. Okay, so those are the base parts. So that is really, we can say it's one part. We classify them all together. Okay, and then we look at the subparts. So it looks like there's a lot of the same similar ones, like this guy here. This is from the tree. The tree actually, we can look at the this is what the tree looks like. So it's got kind of, so it looks like all the full baffles are all under together. So that's kind of a weld type that we're looking for. So we're going to create a new weld type called full baffle. Okay. So we're going to use that. So this one here, we're going to say it's a full baffle. I'm assuming these are all the same because they're all under that same. So what we can do is, the nice thing is when we identify these as all the same, then when we weld them and we figured out how to weld one of them, then we know how to weld all of them. Okay. Now this part here is short inner end, so it's a different type, so we're going to call it a sometimes you'll see that the names, you don't really want really long names because it appends the name of the subpart with the weld, and it gets kind of long. So I'm going to shorten that a little bit, and I'm going to call this, looks like shorten that a little bit, RBA wrap. And then these are mirror images of each other, so we're going to first treat them the same, and then we're going to go back and see if we need to separate them from left and right. So these are called inner stub wrap. This guy looks like he's all by himself. He doesn't have that other little flip on it. So we're going to call this one just an inner end, I think. Okay, so basically that's all we need to do for that. And kind of to explain a little bit more, we also can teach the corners. I'm not going to do that now. We'll see how that fits in. We teach corners because that determines where the part goes on the table. The base parts, as you add parts to this category of base parts, it keeps track of the statistics of each part, like the area, the normal, and it kind of figures out what makes up that part, what characteristics makes up those parts. And so in the future, when you load in another part that's similar to this but maybe slightly different, it'll say, oh, it's probably a base part because it fits in that category, or it's probably a sub part, or it's probably a non-welding part. So statistics are kept on all the parts so that when you bring in the next one, it does the same actions. And then if we look here and we look at these guys right here, like this inner stub wrap, this actually computes the welds right here. You can see there's 6 welds, 1, 2, 3, 4, 5, 6. And if you do not want to weld that, or if you want to cut one in half, or you want to do something to the weld, then you can click here and you can change the welds on how it. So once it finds a weld, then it cuts it in half. Like if we were going to leave that here, we would have to cut that weld in half, and then these would be 2 welds, and then we'd weld each separately because we'd weld that one. We're going to leave it the way it is now, and we can go through all those and confirm the welds, but I think that pretty well specifies this weld family. Okay, so the next thing we'll do is we will load the family in, and we'll select that 2000 series, and then we'll convert it. Okay, thanks.